Hello guys, today's topic is hybridization. Here we will study only hybridization which is involved in single bond, double bond and triple bond of carbon atoms. So first of all we will go with sp3 hybridization. Before going sp3 hybridization we have to know about carbon atom. So carbon atom, ground state of carbon atom is okay. Here 1s, 2s, 2px, 2py and 2pz. So this is the ground state of carbon atom, and now we will see the excited state of carbon atom. This is ground state, and now we will see excited state. In excited state, what happens? This carbon electron will shift to 2pz. Okay, so it will be look like this. This is 2s, this is 2px, this is 2py, this is 2pz. This is excited state of carbon. So you can clearly see that carbon is tetravalent because 4 of the electrons are unpaired, so it is tetravalent. Now we will study sp3 hybridization with the example with an example of, let's suppose, methane. Okay, so we will study first methane. So methane has formula. This is methane, means CH4. One is carbon atom, hydrogen atoms are 4. So this is formula for methane. So what happened? See, here bond making of carbon has involved 2s, 2px, 2py and 2pz. You can clearly see that 2s will be look like this, and if we draw the coordinates, we will see that this is y say, or actually you can denominate it by y or x, whatever you want. This is 2p x and this is 2p z. Okay, so here is one electron, here is one electron, here is one electron, and here also is one electron. So now when the carbon atom will form bonds between 4 hydrogen atoms, how will it look like? It will look like this. This is carbon atom, this is 2s, this is okay, this is 2s, this is 2px, this is 2py and this is 2pz. Here one thing I want to mention, that I have not shown the other side of these orbitals. Okay, you can see that here it is not, here it is not, so I am showing one side only, that side that is making bond with hydrogen. So hydrogen will make bond here, hydrogen will make bond here, hydrogen will make bond here, and hydrogen will make bond here. This is hydrogen, 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 hydrogen. You can clearly see that there are 2 electron finally, there are 2 electron finally, there also are 2 electron, and there also are 2 electron of opposite spin. Okay, so this is the structure of methane. This is angle, this is angle. Okay, so this angle is 109.5 degree. So this is an example of methane. Now I will explain you that what is the structure of ethane. How will the structure of ethane will look like? So what happened, ethane has formula here CH3 and here CH3. Okay, this is the formula of ethane. So we will draw the structure of ethane. This is carbon atom, this is carbon atom, 2 carbon atom, and this is s orbital of this carbon, this is s orbital of this carbon, and here is 1p, here is 1p, and here is 1p. Okay, you can clearly see that this is the sigma bond. This is not pi bond because it is sidewise. This is overlapping. This p orbital is overlapping with this p orbital. So there have been 2 electrons. This will make bond with hydrogen here, make bond with hydrogen here, make bond with hydrogen here. So you can clearly see that all the bonds are sigma bonds. Here also there is sigma bond. Okay, so you can clearly see the structure of ethane. So this is also sp3 hybridization. How we know? Because one is sp3 means 1p, 2p, 3p. Okay, so 3p and 1s character. Here is also 1s character and 3 p's. Okay, so this is sp3 hybridization. Now we will go for sp2 hybridization. Before going sp2 hybridization, sp2 hybridization, we will learn with the help of an example, that is ethene. Okay, we will take ethene as example. So how will ethene look like? It will look like this. Okay, so you can see that there is one double bond in ethene. Now same ground state and excited state for carbon here also is same. We need not to mention again the ground state and excited state again, but here we can see that number of hydrogen atoms are only 4. 2 carbon atoms and hydrogen atoms are 4. So with the previous knowledge we know that this carbon and this carbon. Okay, so here it will look like this, and this. Here also this. Sorry if my drawing is not that good. Okay, this is carbon atom 1, this carbon atom 2, and hydrogen will make bond here. This is hydrogen, this is hydrogen. Okay, and this is also hydrogen, this is also sorry, there are 2 hydrogens, so yeah, Again, I want to convey that I haven't shown the backward side of this orbital, means below the nodal. Okay, for simplicity of structure, just like so. This is one hydrogen, this is another hydrogen, and this is one hydrogen here, this is another hydrogen. So this orbital remains unhybridized. Okay, this orbital of carbon remains unhybridized. Here is sigma bond, here is sigma bond, here is sigma bond, and here is sigma bond. So total number of sigma bonds 1, 2, 3, 4 and 5. This is also sigma bond, but this will overlap. Okay, at downside also this will overlap, but I haven't show it because of simplicity of our structure. So it will overlap sidewise. Downwards also I will show you, this will overlap. Excuse me if my structure is not that good, just I want to make your concept strong. So it will be in 3D, so it will overlap with this, means this orbital will overlap with this orbital. Okay, just for simplicity of structure I am showing like this. So how will it look like? It will look like this. This is a plane of paper, and here is C, here is C, here it is hydrogen, this is sigma bond, this is hydrogen, this is hydrogen, and this is hydrogen, but this is unhybridized orbital, this is okay. This is below the plane, that's why I am showing like this. This will sidewise overlap. So this is pi bond. Okay, so number of sigma bonds 1, 2, 3, 4, 5 and 1 pi bond. This is pi bond. That's why 1s 2 p's, 1 p, okay, 2 p, 1s 2 p. That's why it is called sp2. Now we will learn about sp hybridization. Okay, sp hybridization. So what happens in sp hybridization? We take an example of ethane. C triple bond C H H. This is ethane. Okay. So what happens here? Here two of the orbitals remain unhybridized and rest concepts are same. So this is carbon atom, this is carbon atom. This is S, this is P, okay. So these are, this side is positive, this side negative, this side is positive, this side is negative, this side is positive, this side negative, this side positive, this side negative. So you can clearly see that the hydrogen will bond here. This is hydrogen, this is hydrogen. Okay, so it will overlap sidewise. It will overlap sidewise, and this also will overlap sidewise. Okay, so there are two sidewise overlaps. That's why there are two pi bonds. This and this also pi pi bond. Here is sigma bond, here is sigma bond. So number of sigma bonds are 1, 2, 3 sigma bonds in total and 2 pi bonds. But in this structure, here s character, number of s character in this carbon is 1s, okay, and 1p. There is only one p, that is making p character here, okay. One of p character, one of s character, that's why it is sp hybridization, okay. So that's the hybridization of single bond, double bond and triple bond. So that's all for today. Thank you. If you like my video, then please like and share, only if you like my video, okay. So yeah, goodbye.